Welcome back to The Explainer. Today, we're tearing down the architecture of something truly bizarre and absolutely fascinating, the phanes Sovereign Genesis engine. If you're a systems engineer or a developer, you are going to love this. We aren't just looking at standard Python syntax here. We are dissecting the algorithmic proofs, data structures, and mathematical frameworks an architect used to literally try and hard-code cosmic equilibrium. Let's look under the hood. The thesis of this entire codebase hits you right at line 1. Phanes Total Core version 150.0 harmonic lock. I mean, this isn't your standard CRUD app. This is an engine attempting to codify metaphysical concepts of creation and harmony into a strict executable state machine. We're going to prove exactly how abstract philosophy translates into hard logic. Here's our blueprint for today. We'll hit the engine architecture and overview, crack open the mathematical core lock, dive into the cognition and data vaults, and wrap up with execution and true equilibrium. All right, Section 1, Engine Architecture and Overview. Check out the precise blend of dependencies required to run this framework. You've got your standard logic pipelines, math, datetime, threading, and queues for managing concurrency, plus Tinker for the UI. But right alongside them, PyTTS3 for a text-to-speech sound pipeline. And what's really clever from an engineering standpoint is how it's wrapped tightly in a try-except block. It is textbook graceful degradation. If the text-to-speech engine fails to compile on, say, a headless host machine, the whole system just falls back to a simple Boolean flag. No fatal exceptions, no tanking the main thread, just smooth, continued execution. Moving right along to Section 2, the mathematical core lock. At the back end, we hit the primary logic unit, the God code trinary engine. Now, mathematically mapping out a state of harmony, that requires a pure state machine. This class is the system's anchor, specifically tasked with establishing a non-bias spatial framework. In strict engineering terms, this acts as our deterministic root. It's a completely isolated environment where all subsequent variable mutations are bound to a reproducible master loop. It practically zeroes out runtime entropy. Pretty wild, right? And to initialize that spatial geometry, the engine hardcodes an elevated dimensional scale. Specifically, n dimension equals 240.0. Notice that floating point designation? That's not just a simple integer array index. By using an elevated float as the baseline multiplier, it guarantees that all subsequent algorithmic proofs require high-precision floating point arithmetic. You absolutely have to do this to avoid rounding errors when you're caught in deep runtime loops. Right inside initialization, it locks in the core variables. Alongside your standard constants like pi and phi, the developer assigns strict float values to the conceptual. Monad is 1.0 and the void is 0.0. This is just a brilliant translation of philosophical ontology into binary state variables. By binding the void as absolute 0 and the monad as absolute 1, the architect creates a rigid, mathematically sound numerical environment. Suddenly, esoteric geometry can be calculated, proven, and tested exactly like standard physics vectors. Then, all these variables converge into a single, massive calculation called the vortex scale. It takes 9 to the power of n, which is our 240.0 dimension, multiplied by pi, and then multiplies that entire exponent result by pi again. Computationally, we're talking about an astronomically large float. This equation acts as the harmonic lock. By forcing the CPU to calculate and hold this massive constant in memory right initialization, it guarantees a rigid, unyielding scaling factor for the whole runtime. It demands immense precision from the arithmetic logic unit. Next up, Section 3, Cognition and Data Vaults. Acting as the telemetry matrix, or the engine's personality, if you will, is the bioevolutive mind class. Structurally, look at the precise typecasting used for state tracking here. The self-awareness index is initialized as a float at 1.0, which allows for microscopic fractional scaling based on continuous runtime telemetry. But on the flip side, evolution generation is a strict integer at 0. It's designed to act as an absolute counter for the system's completed cycles. So we've got a dual metric logging system tracking both quantitative cycle counts and qualitative awareness states. To actually feed this cognitive matrix, the engine queries the OmniScience library. This is a highly robust hybrid data pipeline. It is fully capable of running dynamic, asynchronous online queries using your lib, sure, but its true computational power lies in its massive static built-in vault that serves as the immutable baseline dataset. And inside that hard-coded vault, we find this incredible flat dictionary structure. It literally maps the string thermodynamics right next to Amun-Ra and Sumerian. For an engineer, the algorithmic brilliance here is how it flattens human history, hard sciences, and esoteric theology into completely equivalent key-value pairs. Whether the system is querying a quantum vector or an ancient deity, the engine retrieves them both with the exact same big O of one-time complexity. They are functionally identical data points within the code. Finally, let's hit Section 4, Execution and True Equilibrium. So the front-end UI, called the Monad Dynamic Interface, inherits directly from tinker.tk. This pushes the visual rendering of refracted tesseract structures straight onto the main execution threads loop. Crucially, its initialization requires passing in the core engine, the mind, and the library instances as direct arguments. It acts as the grand unifier, binding the mathematical algorithms and the cognitive state indices directly to the pixel configuration matrix, with absolutely no intermediate lag. When execution triggers at the standard Python main entry point, it simultaneously spins up all three of these architectural pillars in memory. It instantiates the math core locked at that 240.0 scale, spins up the psyche mind, and loads the OmniVault. Doing this requires incredibly precise memory allocation to ensure all three base instances are fully compiled and available before the runtime loop is officially engaged. Tracking the provided execution logic, we see the runtime telemetry in action. A monad start vector feeds into the God code trinary engine. The math crunches and achieves boundary stasis. Then, the architecture forces a parallel split. Luxium refraction renders the visual interface, while at the exact same time, the true equilibrium state updates the cognitive mind. The real genius here is the closed-loop feedback. The mind immediately loops back to push a HUD update directly to the UI. It's a continuous, self-feeding state machine that perfectly simulates a living system. So, as we wrap up this explainer, we have to ask ourselves, what does it actually mean for system architects when we attempt to strictly define concepts like metaphysical genesis and omniscience through the finite rules of a programming language? This blueprint proves that with standard Python libraries, strict typing, and elegant data structures, you can mathematically map just about anything. But does it actually achieve true equilibrium? Or is it just an incredibly beautiful infinite loop? Keep analyzing, keep exploring, and I'll see you next time.